Okay, this one we're going to talk about how to expand a binomial. And you guys know there's a couple ways to expand a binomial. One of the ways is just to kind of go straight at it. If they gave you a plus b squared, like this, a plus b squared, you could write it out, you could multiply it out. That'd give you a squared plus ab plus another ab plus b squared, which then comes out to be a squared plus 2ab plus b squared. Now be careful. A lot of students make the mistake that they think they can take a plus b to the n. In other words, they could take like a plus b squared and just write it like this. And that's not true. As you can see, this is the answer we want. And this is not the answer we want. So you can multiply it out. However, it could get a little tricky the more you do. In other words, like, what if I wanted to do these first 5? Well, anything to the 0 power, you know to be 1. So you got that one down. A plus b to the 1, that one's pretty easy. That's just a plus b. We just did a plus b squared, so that was a plus 2a squared b plus b. Sorry, a squared plus 2a squared b plus b squared. We just did that. To get this one, you could take a plus b and multiply it to a squared plus 2ab plus b squared. Distributing out, you get a cubed 2a squared b plus ab squared. Then multiplying here, you would get another a squared b 2ab squared, then a b cubed. Combining like terms, then, we get a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Now I'm going to let you do a plus b to the 4th and a plus b to the 5th, but if you do them, then you're going to find out that this it is. So here it is. These are the things we're looking at right here. Okay? Now, that's kind of a cool looking triangle thing. And I'm going to show you how it relates to this thing called Pascal's triangle. So there was a French mathematician named Pascal, and he discovered this thing called Pascal's triangle. Now, how in the world do you get Pascal's triangle? Well, I'm going to show you, okay? So, a couple patterns before we get to Pascal's triangle is we do want you to recognize the pattern. That take a look. When we were at the 5th term, we started with a to the 5th, a to the 4th, 3, 2, 1. This is a to the 0. Now notice back here we have b, which b is the 2nd term. B to the 5th, 4th, 3rd, 2, 1, b to the 0, which is just 1. So notice that your exponents, the first term, starts with a to the 5th and works its way down, while the last term, b, back here starts with b to the 5th and works its way down. Or you could say works its way up to b to the 5th, however you want to look at it. That is definitely a pattern you're going to want to recognize. So, how do we get these numbers here in front of all these? Because we see that a plus b to the 8th, that would be 8, 7, 6, 5, 4, 3, 2, 1, 0, then 8, 7, 6, 5, 4, 3, 2, 1, 0 on the b's coming back. We want to get these other things. So this French mathematician, Pascal, he came up with this triangle. Now, I'm just going to kind of show you this part of it right here, okay? Basically, he asked himself, how many different ways could I get to each position? Well, to get to this position, there's only one way. Think of like the game Plinko on The Price is Right. You drop a Plinko chip and it hits that first peg. How many ways can it hit that first peg? Well, only one way, and that's to drop it right on it. Boom. Now, once it's that first peg, it can either go to the left or it could go to the right, and it's going to hit another peg. So how many ways can it get to this peg? Well, only one, by hitting it and going to the left. How many ways can get to this peg? Only one, hitting it and going to the right. However, there's a peg right here, a peg here, and a peg here. The question is, how many different ways can it get to this peg right here, this one here, and this one here? Well, to get to the one on the sides, it would have to stay hit come to the left, stay to the left. There's only one way for that to happen. To get to this peg on the right, it would have to hit and stay to the right. Only one way to happen. Now, get to this middle peg, though, it could have went left and then come back to the right, so one way there. Or it could have went to the right and then come back to the left, so one way there. Adding that up, that means there's two different ways it could have got to that peg right here. Okay, we're going to have another set of pegs, again, right here in between them. Question is, how many different ways can we get there? Well, to get to this outer one, there's only one way, and that would be for it to stay to the left. One way here to stay to the right. But to get to this peg, well, I'm already at 2 here, so I could bring in the 2 here. And I could bring this one in from here, so 1 plus 2 is 3. I got 2 ways here, it could get there, or 1 way here, it could get there, so 2 plus 1 is 3. So to get to the next row of Pascal's triangle, we get the ones on the outside, and then we just take 1 plus 3, that's 4, 3 plus 3, 6, 3 plus 1, 4. Done. Next row, 1, 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, 1. Done. Take a look. Here's a nice version of it right here. How does that relate to what we just did over here? Well, if you remember correctly, a plus b to the 1 was 1a plus 1b. A plus b squared was 1a squared plus 2ab plus 1b squared. ab to the third would have been 1a cubed plus 3a squared b plus 3ab squared plus b cubed. This would be 1a to the fourth plus a to the third, b to the 1, a squared, b squared, a to the 1, b to the cube, and then b to the fourth. Here we're going to get a to the fifth, a to the fourth, a to the third, a squared, a to the 1, a to the 0. Here we have b to the fifth, b to the fourth, b to the third, b squared, b to the 1, and plus signs in between. That's how we relate Pascal's triangle to the binomial expansion theorem. Okay, so let's take a look. If we wanted to, let's see, so expand a plus b to the 7th, no problem. We want to go to the 7th row of Pascal's triangle. So I do that quickly. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. I'm just adding them up. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1, 1, 5, 10, 10, 5, 1. I got to get down to the 7th. So 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1. There it is. I know it because that second number is a 7. So since that second number is a 7, we're good to go. So there's our coefficients. 1, give yourself some space. 7, a little bit of space. 21, a little bit of space. 35, a little bit of space. 35, a little bit of space. 21, a little bit of space. 7, a little bit of space. And 1. In fact, I'm going to go ahead. Oops. Sorry about that. I'm going to put that 1 down here, just so I don't run out of room. Now I start out with a to the 7th. Then I go down. 6, 5, 4, 3, 2, 1, 0. B, I start down back here. B to the 7th, 6th, 5th, 4th, 3rd, squared, 1, 0. Plus signs here, here, here in between them all. Stick a fork in it, folks. You're done. You just expand using Pascal's triangle. All right. Now there is another way to do that. I'm going to show you that in the next video. So, hope you enjoyed Pascal's triangle. We're going to show you the next one called binomial expansion using something else. Okay. See you in a second. Bye.